Hi, so this is our next topic, which is the three laws of motion by Isaac Newton. Now, Newton's law, we have three laws. We have the first law of motion, the second law of motion, and the third law of motion. So first, we will go to the first law of motion. So the first law of motion is also called as the law of inertia. So law of inertia. What is inertia? Okay, now so many knows, or let's say many knows about inertia, but they cannot explain it well kung unsa gid na siya si inertia. So first is, let's go back to motion. So what is motion? For the past topics, we have described motion through words, graphs, diagram, numbers, formulas. We had the four kinematic equations. No, so gi-describe ra nato ang motion through that. No, so like velocity, speed, acceleration, four kinematic equation, free fall. Okay, so those are just the descriptions. But here on the Newton's law of motion, we will discuss, or we will explain why there is motion. No, kay katong task na to ng mga discussion is all about describing what is motion. Karon is i-explain na nato why motion exists. Okay? So ngano ing-ani ang mga motion sa mga butang. So here is the three laws of motion. So first is the Newton's first law of motion, also called as the law of inertia. It says an object at rest stays at rest, and an object in motion stays in motion with the same speed and in the same direction unless acted upon by an unbalanced force. So what do you mean by this? Okay, so here we have this branch. Okay, so ako sang Okay, so we have this branch. It says here, if the forces are balanced, what do you mean by balance? It means walay sobra, na-cancel out sila. Okay, so naay duha. Okay, duha na pwede niya na result. Okay, so if the forces are balanced, first, the object will remain at rest, or the object will be at rest. So pag at rest siya, the velocity is 0. Okay, of course, you're not moving, so the velocity is 0. Next is, if the forces are balanced, the objects will be in motion. Okay? Pwede siya in motion. So, if it is in motion, your velocity is not equal to 0. Okay, so because it's moving. Okay? Now, if your object is at rest and the forces are balanced, it will stay at rest. Okay? Since it will stay at rest, it means your final velocity and your initial velocity is 0. Ano naman, because it stays at rest. So 0 minus 0 is 0, of course. It means your acceleration is 0. There is no changes in your velocity. Walay change in velocity, and that is acceleration all about. Because acceleration is the change of velocity over time. No? So now here on the other side, if the objects are in motion, then the velocity is not equal to 0. Let's say you have a velocity of 5 meters per second. If you have this velocity, then it will stay in that velocity, in same speed or in same direction. So it is like final velocity minus initial velocity, 5, nagstay man ka, and 5 is equal to 0. So it means both of them will have an acceleration of 0, whether the object will stay at rest or the object will stay in motion. So remember that in the first law of motion, the acceleration of your object is always 0. Maski ma-rest man siya or in motion. So it will be 0. Kay wala may changes na hitabo. No changes in the velocity. So the behavior of all objects can be described by saying that objects tend to keep on doing what they are doing unless na ay unbalanced force na mag-act sa ilaha. So, if nakarest siya, they will continue to be at a state of rest. If motion po siya, let's say eastward velocity of 5 meters per second, they will also continue in the same state of motion. 5 meters, 5 meters per second going east. Okay, so that is the law of inertia. No, so possible na siya if the forces are balanced. What do you mean by forces are balanced? Pag walay external forces na magpalihok sa iyaha or imuhang ihatag sa iyaha, the forces are balanced. It is at rest and it will stay at rest. It is moving and it will keep on moving. Kaya wala man nimo siya gihilabtan. No, so that is the law of inertia. Next is, for example, we have this. No? So, for example, you have this oval track. Okay? So for a girl here is carrying a basin full of water. Now, if mudagan ni siya, let's say from rest, it will start to move on this direction. Then mapansin nato or we can guess that this girl carrying a basin full of water, pag andar ana niya og lakaw ani diri ana direction, na ay mga tubig na nayabo. Okay? That is because ni change ang iyang velocity. So velocity niya dira is from 0, then ni move siya, so the velocity is not equal to 0. Okay? Next is, if it will, kung kunwari na siya yung velocity, it will stay in this area. It means same ang iyang velocity diri ana area because it is just straight track. Pero pag abot niya diri na part, sa mga curved na part, it will now have another change. Nga naman, even though, let's say your velocity is 5 meters per second, even though that it will stay 5 meters per second on this area, or kanina mga places, need change man ka og direction. And when it comes to acceleration can be a change in velocity or mag-change siya og direction. Okay? So, here, even though, let's say, na mag-stay ang imuhang velocity, kay nag-change man kag direction because it is a curved track, na time pod na kaninga girl is maspill ang iyang gigunitan nga basin or na water. Okay, so kanina part. Now here in this part, kung straight ra gid na siya with the same velocity, then walay mayabo sa iyang water. Pero diri ana pod na part is nanapoy mayabo because it is a curved path. So there is a change in direction. And then, since nag-move pa siya diri, and then pag-stop niya diri anapod sa ato ang starting line, which is also our finish line, so pag-stop niya ana, gikan siya og velocity nga 5 meters per second, nag-stop siya into 0. Okay? So, nag-change na pod ang iyahang velocity. So, dira from the container, nagikan sa rest, kaning diri as sa starting line nato, if you attempted to move it, na kay change or resist nimo ang kanang change. Okay, so you're what do you mean by resisting the change? It means na ang water ug ang girl are moving at the same directions. Kay gibit-bit man sa girl ang basin. Okay? So gibit-bit niya, so it means the water, the basin full of water, and the girl are moving at the same speed and the same direction. Now, if mag-change og direction si girl, si basin, walay makapugong sa iyaha. Or sa water nga nasa basin, walay makapugong sa iyaha. Okay? Ang girl, pwede niya mapugong ang iyang self. But the water inside the basin, walay magpugong sa iyaha. So if mag-change ang direction ni girl or mag-change ang velocity ni girl, si water must spill siya because there is nothing that can stop the water from moving. No, so walay mag-resist, walay maka-stop sa water sa mga changes na gibuhat ni girl. So that is why here in this part here, kaning mga nag-change. Let me do that. Okay. So this part here na pag gikan sa rest to mag-move siya. Then nag-curve ang iyahang path. Nag-change kag direction. O gikan ka og move, then ni-stop kag kalit. Kana na mga instances ang pwede ma-spill ang water. So what do we mean by that? It means that the water has its own inertia. So inertia di ay gyud. Okay? So isa na sila sa mga examples sa inertia. The girl and the basin full of water. No, walay maka-stop sa water kung mag-change og direction si girl. Okay? So that is what we call the applications of the law of inertia. For instance, you're riding on a train. Naka sa train and you are, let's say, having a nice coffee. Okay. So, pag mag-stop, or let's say, kung hindi train, bus na lang, or let's say, multicab, or any vehicle that you are riding on. So, if you are on that vehicle, and you have this coffee in your hand, and kalit ni stop ang car or ang vehicle, there will be instances that the coffee in your hand or on your hand will spill. Nga naman. It is because the bus stop or the vehicle stop. If naka-seatbelt ka, then naay makapugong sa imuha. But the coffee inside your cup, walay maka-resist para sa iyaha. So that is why na instances that must spill ang coffee because of that. Okay, because it has this state of motion. Or I mean, naka-attrest man good. Let's say attrest ba? No. State of motion ang imuhang coffee together with the vehicle. So baliing anin niya siya. Ikaw nasa vehicle, let's say ang vehicle. Then on a vehicle naa ka. Okay, so the person. And with you is your coffee. So if mag-move ang imuhang vehicle, o let's say 10 meter per second, no? Ikaw pod, nga nag-ride sa vehicle, is also moving at the same velocity with your vehicle. And the coffee with you is also the same, also having the same velocity as you and the vehicle. Okay? So pareho mo nga nag-move of the same velocity. So, kung ikaw is naka-seatbelt ka, mag-stop ang imuhang vehicle. So from 10 meter per second, it stopped. So it became a zero. It became zero. Kanang abrupt na changes sa imuhang state of motion. Okay. So, pag mag-stop sa vehicle, the person, kung walay magpugong sa iyaha, mura siya ma-push forward. Diba? So, sa kanang magsakay mo og multicab and then makalit og stop ang multicab or ang car makalit og stop niya wala ka nag seatbelt, mura baya kag kanang ma-push forward. Why is that? It is because of our resistance to change, and that is inertia. Okay, because of our inertia. No. So inertia is like resisting the changes. So from 10 meter per second na velocity, so nag-move ka, tapos nikalit og change ang direction, change ang direction or ni-change ang velocity, no? So, ikaw nga nag-move together with the vehicle is nag-change, gina-resist nimo ang change na ginahimo sa vehicle. Inertia. That is inertia. No? So, pero if naa kay seatbelt, naay mukugong sa imuha. Okay, so that is also why we need seatbelts. Okay, para siya ang pugong para sa sa motion sa atong vehicle because of the vehicle. No? So if na kay seatbelt, of course, your motion will be stopped. Dili kayo siya delikado para sa imo. But if you have a coffee in your hand, just like this one, walay mo pugong sa coffee. Okay? So the coffee inside your cup will be spilled kung wala siya nakataklob. Okay? So, it will be spilled kay wala may mupugong para sa iyaha tungod sa it is moving along with you. Okay? So, ingana ang application sa Newton's first law. So, for example, here. No? So, the man on the upper sata, diri sa pinakauna. So, on the upper one, the man and the blue car, is moving together. Now, walay seatbelt si person. So, pag mag-change og velocity si car, magpabilin og in motion si tao. Nga naman, it is because wala may nag-stop sa iyahang motion. So, for example, another explanation, no? So, if your car is moving this way, you are also moving that way in the same velocity as the car is. Now, if wala kay seatbelt and mag-stop ang imuhang car just like here na nabangga siya, wala kay seatbelt, ikaw magpabilin ka in motion. Okay, so you will remain in motion kay wala may mag-stop sa imuha. You have no seatbelt. Okay, so also this one. Sa kaduha, we have the truck and the ladder. Let's say wala niya na secure ang ladder or anything that is nasa taas niya. So once the ladder and the truck is moving together, once na wala nimo na secure ang ladder sa taas and then mo stop kalit ang car or ang truck, your ladder will remain in motion. And that is because of inertia. No? So, ingana si inertia. That is why inertia ang ato ang focus when it comes to cars. Why? The reason that we have safety belts, why we have airbags, and that is because of the Newton's first law. No? Para lang na ay mo stop sa imong motion. Okay, so na mo stop sa imong motion kay even though you are moving together with the car, wala may makapugong sa imuha. Unless mag-seatbelt ka or mag-airbag ka. Or na airbags. You know, sa mga accidents, there are airbags. That is to prevent you from going beyond the windshield. Okay, so we have the inertia. So the first law of motion states that an object at rest stays at rest and an object in motion stays in motion with the same speed and the same direction unless acted by an unbalanced force. What do you mean? Unless acted upon by unbalanced force. So sa atong example ganina, ang unbalanced force dato diri is kaning mga gibanggaan nila. Okay, so they are in motion and they should be doing that continuously, pero kay nakabangga man sila, so naay gi-introduce nga unbalanced force sa ilaha. So, from motion, mo rest na dayon sila. Okay, so that is what they mean by unless acted upon by an unbalanced force. Now, that is for object in motion stays in motion unless acted upon by unbalanced force, mo stop siya. So, while for at rest, let's say at rest ang imuhang object, gihatagan nimo siya og unbalanced force. So that is the time that your object at rest will now move because of your unbalanced force. Now, here in the object in motion, stays in motion, hatagan nimo siya og unbalanced na force, then mo stop siya. So ana siya, mura siya mo opposite pag hatagan nimo og unbalanced force. Okay? So the objects tend to keep on doing what they're doing. In fact, the natural tendency of the object is to resist changes in their state of motion. Mo resist sila og changes. So if you are moving with a car, ni stop ang car, ikaw na kay resistance sa change na gibuhat ni car. So you will also move gihapon, no? So kung wala kay seatbelt, ano na dayon ka sa windshield or mabangga ka sa tubangan nimo, something like that. Okay? So this tendency to resist changes in their state of motion, kana siya si inertia, no? The resistance to change in your state of motion. Okay? So ngano di ay na kanang ngano di ay na kanang usa day naka-inspire kay Newton ngano naman siya first law of motion, second law of motion, third law of motion. Okay? So, story time. Before, no, lahi ang pagtuo sa mga tao. They do not have this thinking na an object at rest will stay at rest and an object in motion will stay in motion. Wala na sila. Ang ilaha is, yan eh. So, people believe before na kanang na-formulate ni Newton ang three laws of motion, ang ilahang pagtuo is that kung mag-move ang object, pagkadugayan ana is mag-rest na dayon siya. Which is, makita naman po nato siya in real life. No, na kanang pag naatay i-move na mga objects, then eventually it will stop. No, so pag mag-move siya, then need na po nimo siya i-push para mo kalit o mo continue siya og move. That's what we have observed bisan karon, no? So that is why many of the people believe that a force is necessary para mapadayon og move ang isa ka object, no? So because it will eventually stop. Mao na ilang pagtuo na tungod sa mo stop man siya kag kadugayan, dapat hatagan nato siya continuous na force para mupadayon siya og dagan, no? So pero pag imuha siyang pasagdahan ang isa ka object, eventually that moving object will stop, no? So mo na siya ang thinking sa mga tao sa una na we really need a force para move ang object. Kaya wala na sila ang mind na an object in motion will remain in motion. So for nearly 2,000 years prior to Newton, mo na siya ang ilahang gibelieve na it is natural tendency of all objects to assume a rest position. Eventually, all the moving object will be at rest. An object will remain at rest. Para sa ilaha, an object will remain at rest. An object at rest will remain at rest, and an object in motion will eventually stop. O na siya ilahang thinking. Okay, for nearly 2,000 years. Okay, then here comes Newton. No? Gi-introduce niya ang first law of motion, yung law of inertia. And imagine the uproar that it made Kay 2,000 years nila tuuhan ni siya. So pag syempre pag ikaw kani imong belief i-introducean ka kanang i-introduce sa imong another belief, another like another law ni Newton na discover ni Newton or na-formulate ni Newton, of course, you would not believe Newton at first. Kay 2,000 years gani mo, imong mga ancestors, mao ang mga tinuuhan. And then, here comes Newton saying that your belief is not true. Diba? So, it caused an uproar. Wala dayon i-accept sa mga tao ang first law ni Newton. Because it seems impossible. No? Impossible para sa ilaha. Because kung tanawon mo po nato in real life, tanawon nato today, no? Eventually, mong good. Diba? Kung magpa-move ta og bola, it will stop. That's what we have observed. So, dili nila mag-grasp ang idea ni Newton na nganong an object in motion will remain in motion. Kana ang ilahang clause na kanang dili ma-understand. Nganong mag-remain man siya in motion. Okay, now, here comes Galileo Galilei. So, ang naka-inspire anak kay Newton is actually Galileo Galilei. Okay, ani si Galileo Galilei. Yun siya, na iyahang gitest actually ang inertia. Inertia lang iyahang gitest. Yun siya, kung wala daw friction, no? Experiment na siya. At first is this part here. Mani siya iyahang experiment. Kung walaon daw, or not experiment, but iyahang idea, na kung walaon daw si friction, kung magpadagan ta og bola, aning angle, okay, so padaga, mo siyang i-drop ang ball, eventually, daw, it will fall down, and mubalik daw siya sa same height kung asa nimo siya gi-release. So, if you released it here, ang final height ana niya will be the same kung asa nimo siya gi-release. Ana si Galileo. No? So, with a steep angle, a ball will roll a small distance to attain the original height. So, ana si Galileo Galilei na the ball has this goal. Kunyari, kung imuha siyang ipadagan, kung walay friction, imuha siyang ipadagan, ang ball na siya goal na dapat ma-attain niya ang former height, ang height sa kung asa siya gi-release. No, dapat same ang iyahang height sa iyang pag-release o sa iyahang final pod na height. Okay? So, kung mas steeper ang angle, kani steeper, steep ang angle. So, pag ato siyang ibaylo na po ang angle, no? So, i-reduce na to ang angle niya sa iyang inclination. So, the ball, mag-roll siya og farther distance, mas dako ang distance na iyahang i-roll para lang ma-attain niya ang the same height. No? So, bahalag layo, basta kay ma-attain daw niya ang iyang final height. Same height sa iyang initial height. Okay? So, what happens if the incline or the opposing incline is not inclined? So, what do I mean by that? What if imo siyang giparol dire, pero ang pikas dili na siya inclined? What if it is already a line, no? Horizontal line. No? So, if the ball stops, para mo stop ra ang ball, pag ma-attain niya ang iyahang final height nga dapat pareho og height sa iyang initial height. Kung ingani ang ball, horizontal line ang iyahang opposite, then the ball will never stop. It will never stop moving kay dili man niya ma-attain ang iyahang final height nga mo equal sa iyang initial height. So, it will roll forever. Forever siya mag-roll kay dili man niya ma-attain ang iyahang goal. Okay? So, that means That means that, oh, wait lang, that if the friction were absent, if the friction were absent, then your the object will roll forever. So dira na murag na formulate ni Newton ang iyang first law of motion. No, na kanang if an object at rest will remain at rest and an object in motion will also remain in motion because of this idea from Galileo Galilei. No? Na pag walay friction, the ball will continue on moving kay dili niya ma-attain ang iyahang final height na same og height sa iyang initial height. Okay? So that is the similarity, kanang similarity sa idea ni Galileo and ni Newton about inertia. Okay? So it means that forces is not needed para mo continue og move ang isa ka object. Pareho sa kay Galileo ganina, it will move on its own. No? If walay friction. Okay? So Newton's first law of motion declares that force is not needed to keep an object in motion because it will continue in motion. So wala nay pulos ang imong paghatag og force sa isa ka butang na mag-continue og move, di ba? So in actuality, kung ihatagan nimo siya og force ang isa ka butang nga nag-move, mag-rest na noon na siya. Okay? So because it tends to be opposite. So ang object at rest, hatagan nimo og force, mo-move siya. An object in motion, hatagan nimo og force, mo-rest siya. No? So that is why an object that is moving, dili nimo siya hatagan og force. If ganahan ka na, mo-move siya continuously. Okay? So, mass. Mass is a measure of the amount of inertia on an object. So, all object, it resists changes in their state of motion. Tanan objects, basta na ay mass. Okay? So, all objects have this tendency, what we call inertia. So, basta na ay mass ang isa ka object, then naa siya inertia. Okay? So, as long as you have a mass, you have inertia. And it is directly proportional to each other. What I mean by directly proportional, if dako ang imong mass, then your inertia is also big. Okay? So you have a massive inertia if you have a mass, you're a massive object. No? Kung na a massive object. Okay? So a common physics demonstration relies on this principle that the more massive the object is, the more that object resists changes in their state of motion. Okay, so ana siya ang relationship between mass and inertia. The more massive you are, the more you have inertia, the more you resist change. Okay, so for example, imagine a place in a cosmos far from all gravitational and fictional influences. Suppose that you visit a place, just suppose, and throw a rock. The rock will A, gradually stop, B, continue in motion in the same direction at constant speed. Okay, so naa daw ka sa cosmos or sa space, then layo sa frictional and sa gravitational influences. Okay. So for if you throw a rock, what will happen to the rock? A, gradually stop. B, it will continue in motion. Here is githrow man nimo ang rock. So it means you gave the velocity is not zero. Githrow nimo siya. So gihatagan nimo siya og velocity. Githrow nimo siya. Okay? So an object, diba, first law of motion, an object in motion because it has velocity, an object in motion, of course, will remain in motion. So the answer here is letter B. It will continue in motion because it has a velocity. Based ato ang first law of motion. So the answer here is letter B. Now for number 2, let's say here, a 2-kilogram object is moving horizontally with a speed of 4 meters per second. So how much net force is required to keep the object moving at this speed and in this direction? The answer for this is 0. Why 0? It is because it is already moving. An object in motion will remain in motion. So you do not need any force to keep the object moving because it will move on its own. Okay, that is for the law of inertia. Next, Macintosh are arguing in the cafeteria. Max says that if he flings the jelly with a greater speed, it will have a greater inertia. Josh argues that inertia does not depend upon speed, but rather upon mass. Who do you agree with and explain why? Now here, they are arguing. Mac says that the greater the speed, the greater the inertia. Tosh pod is ningan siya, it does not depend on speed, but rather upon mass. So who do you think is correct? Okay, so based on our discussion about mass as the measure of the amount of inertia, so that means si Tosh ang tama. Ano? So remember that inertia has nothing to do with the speed. It's not about speed, but it is about mass. Okay, so if you the more mass you have, the more inertia. Dili kay siya connected about sa speed gid kayo. No, dili siya connected in that way. Okay, so inertia depends solely on mass. Okay, so the more massive you are, the more na resist ka sa changes. Okay, so that is why it is Tosh that is correct here. Next is, supposing you were in space in a weightless environment, would it require a force to set an object in motion? Okay, so here, the answer is yes. Why? You were in a space in a weightless environment. Wala siya ningon na nag-move ka. Okay? Because if nag-move ka daan, o nakay velocity or nakay speed, then you would not require a force. Okay, mag-move naman ka dayon. You will continue moving. But wala siya giingon dire na nag-move ka. Ingon na siya, naka sa space. Okay? So, it means your default nga velocity is 0. Your velocity is 0. You are at rest. So, since you are at rest, you need a force para move ka. So, the answer here is yes. Okay, so unless stated na kanang nag-move ka, okay, unless stated na nag-move ka, assume that this situation here is at rest. Okay, so you don't have an acceleration. Nga siya, wala siya ningon na nag-accelerate ka, na kay velocity. So, based on first law, you will remain at rest. So, you need force to set an object in motion if it is at rest. Next here is number 5. Fred spends most Sunday afternoon at rest on the sofa, watching pro football games and consuming large quantities of food. Right. What effect, if any, does this practice have upon his inertia? And explain. Okay, so if Fred likes to lounge around and consume large quantities of food na siya'y effect sa iyang mass. Okay? So, since na siya'y effect sa iyang mass, the more na mo gain siya og mass, the more na mo gain pod siya og inertia. Now, so that is the relationship between the mass and inertia. No? So, sa may kani siyang iyang habit, maka-increase sa iyang mass. And pag mo-increase ang iyang mass, mo-increase pod ang iyang inertia. I hope that's clear. Next is Ben is being chased through the woods by a bull moose that he was attempting to photograph. The enormous mass of the bull moose is extremely intimidating. Yet, if Ben makes a zigzag pattern through the woods, he will be able to use the large mass of the moose to his own advantage. Explain this in terms of inertia and Newton's first law of motion. So, since ningan man siya diri, the bull has an enormous mass, so we can say that the bull is more massive than Ben. So, what does that mean? Means mas dako siya og inertia. Diba? Mas dako og mass, mas dako og inertia. Mas dako og inertia, it means mas mo resist siya og change. So, ang gibuhat ni Ben na nag-make siya zigzag pattern is actually a great idea kay maglisod man og change og direction si bull moose. And that is because dako man siya inertia. So, dako inertia, mas dako ang iyahang resistance to changes in direction, changes in velocity. No? So, if mag-zigzag pattern na si Ben, dili dayon makaapas ang bull sa iyaha. Okay, so that is the explanation based on the inertia and the Newton's first law of motion sa gibuhat ni Ben. Next is, let's say that two bricks are resting on the edge of the lab table. Shirley stands on her toes and spots the two bricks. So, ganahan daw siya na makabalo kinsa ang mas bugat or say more massive ato nga brick. Pero dili daw niya maabot para i-lift ang mga bricks. Dili daw siya taas kaayo para ma-lift niya ang bricks. Dili niya maabot para ma-lift niya ang bricks. Pero she can reach high enough para i-push ang mga bricks. Okay? So, discuss how the process of pushing the bricks will allow Shirley to determine which of the two bricks is most massive, and what difference will Shirley observe, and how can this observation lead to necessary conclusion. Okay? So, usay pulos anang iyahang pag-push sa mga bricks ni Shirley. Diba? So, it all comes to inertia. Inertia. So, the more inertia, the more mass. Pero how will we know na dako siyang inertia? Okay? So, katong pag-push ni Shirley, kung kinsa tong medyo resistant or kanang dili kayo niya ma-push, it means mas dako ang iyang inertia. Okay? Sa kanang lisod kayo siya i-push kaysa sa other brick. Then it means mas dako ang iyang inertia kaysa atong isa ka brick. So, the more inertia it has, the more mass. The more na maglisod siya og push, the more na mas dako ang inertia ato na brick, the more mass it has. Okay? So, mo na siya iyahang giunsa niya pag-determine kung kinsa ang mas massive sa ilaha duha. So, depende na siya sa iyang pag-push. No? So, pag-push niya sa isa is dali ra niya na push, pero ang isa kay dili kaayo. So, it means katuwa ang naglisod siya og push kato nga brick ang mas dako og inertia og mas dako og mass. Okay? So that is the observation that Shirley made with the two bricks. Okay. So State of motion. So, sige discuss ganina. So, unsa ang state motion? No, the inertia is the resistance to the state of motion. But what is state of motion? Inertia, it is the tendency of an object to resist changes in its state of motion. Pero sa day ng state of motion. Okay, state of motion of an object is defined by its velocity or the speed with a direction. So, thus, inertia could be said or kanang pwede nato siya ma-redefine as the tendency of the object to resist changes in its velocity. So, kung mag-resist siya og changes sa iyang velocity from rest to moving or from moving to rest, no, nag-resist siya sa kana ng mga changes, then that is inertia. Or we can also say that inertia is the tendency of an object to resist acceleration because katong pareho sa ato ang example ganina na mag-rest man ang atong object or mag-motion. Okay. Rest man siya or in motion, they both have a zero acceleration. Okay. So, it means sa first law of inertia, there is no acceleration. Okay. So, what if, ma'am, naana siya acceleration? Dili na siya sa clause sa first law of motion. No? So, if it has acceleration already, then it is not covered by the first law of motion. Dito ana na siya sa second law of motion, which is what we will discuss after this. No? So, for example, we have here another problem. So, let's say here, a group of physics teachers is taking some time off a little putt golf. So pinakalas daw na hole is nada siya metal rim. Kaning metal rim. Okay. That the putters must use to guide their ball towards the hole. So, Mr. S guides a golf ball around the metal rim and diri ang ball, then mo take niya ani nga path, and this is the hole of the golf. This is the golf hole. Okay. So, when the ball leaves the rim, which path will the golf ball follow? Siyang i-follow nga path kung kunwari wala niya na shoot dira sa ato ang golf hole. So si 1 ba, si 2 or si 3? Okay? So based on the first law of motion, object will remain in motion. An object in motion will remain in motion with the same speed and same direction. No? So, here, kung asa siya gikan, diri aman, ang path na iyang i-take is si number 2. Nga naman. As you can see here, it is a bit of straight na line. No? So, it will also have that direction. Dili siya pwede 1 because it is very, mag-deviate na kayo iyang direction. Pwede ang 3, pero, as you can see here in our metal rim, wala man siya ni curve. So, pag ni-curve siya gamay, then maybe pwede si 3. But since it ends at a straight line, ang metal rim is nag-end siya at a straight line, so that is why the answer is number 2. Okay, so the same man dapat siya direction. Okay, so that is why it is number 2. Next. A 4.0 kilogram object is moving across a friction-free surface with a constant velocity of 2 meters per second. Which one of the following horizontal forces is necessary to maintain this state of motion? Okay, so we have A, 0, B, 0.5, C, 2.0, D, 8.0, E depends on the speed. So the answer here is 0. Why? Because we are in the first law of motion, naa na siya 2 meter per second na velocity daan. Constant pag yun. Okay? So, an object in motion will remain in motion. So, it is not, a force is not necessary to maintain its motion. So, that is letter A. Okay? Oh, okay. So, then we will have balance and unbalanced forces. So, ganina atong i-discuss sa first law of motion is about balance forces. Kung balance ang imong forces, mo ni siya ang mahitabo. At rest or in motion. Pag at rest, it will remain at rest. Pag motion, it will remain in motion. Balance man good. But first, unsa day ning balance forces? Unsa day ning unbalanced forces? Kanus ang ma-balance ang forces, kanus ang ma-unbalance ang forces. Okay? So, let's say we have this book. Okay? So, si book, na siya weight, right? Because it's an object. It has mass. So, if it has mass, it has weight. Okay? So, weight is a downward force. So, naa siya force that is pulling it downward. Okay, so naa siya force that is the weight, or what we call the F grav. No? That is the force of gravity that pulls downward on the book. Okay. So then, if naa siya sa surface, ang ato ang book, surface like a table, floor, ana, naapoy force na mag-act sa iya ha. So because of its weight, kung naa siya sa surface, naatay ginatawag nga normal force. So nang normal force? Normal force is the force that a surface exerts back to the object. No? So kanini, na may weight si book. Tapos pa downward siya. Tapos since naman siya sa table, let's say na siya sa table, na siya sa floor, ang floor pod is mag-exert pod og weight, not weight, og force pabalik sa iya ha. No? So kung pila ang iyahang weight, maupod ang iyahang normal force. So if it has a 5 Newton nga weight, then the normal force is also 5 Newtons. Okay? So, if na siya surface. Okay. So here, since we have 5 na upward, 5 na downward, so let's say, ang upward, diba sa ato ang Cartesian plane, they are both in the y-axis. Isa silang axis. Ang isa lang is going up. So, kung going up siya, that is positive. And then, your weight is going down, so it is negative. Okay? So, positive 5 newtons minus 5 newtons. Syempre, they will cancel each other out. You get what I say? Kaya ang isa upward man, ang isa kay downward, unya pareho pagid sila og magnitude, then we can say that this book is balanced ang ilang force. Balance kay na cancel out man sila. Okay? So that is balanced force. Another example, we have a person. Okay? So kung pila ang weight ni person here, mo na siya ang downward force. Let me check. Okay, mo na siya si downward force. Ang iyahang weight, or the F grav, FG. Okay, the force of gravity. Now, since naman siya sa floor, napod siya normal force. Yung naga-push upward sa person. No? So, kung pila yung weight, let's say that is 50 newtons. So, ang normal force pod nimo is also 50 newtons. Okay? So, with that, the forces on the person are also balanced, kina-cancel out man sila. If opposite galing ilahang direction, you can cancel them out if pareho sila og magnitude. Okay? Parang magnitude pareho value ba? Value. Okay? So, here there are two forces acting upon a person. The force of gravity exerts a downward force. Now, remember that the force of gravity is always downward. So, wala kay makita nga gravity nga sideways, upward, wala siyang ana. Because it is a downward force. Okay? Now, the floor also exerts an upward force. The same sa force of gravity. Since these two forces are equal magnitude but opposite ang ilang direction, they will balance each other. So, pag balance gali ang imuhang forces, we can say that the forces are at equilibrium. Equal ang ilang forces. So, there is no unbalanced force acting upon a person and thus the person maintains its state of motion. Diba? Sa first law of motion, dapat forces are balanced para ma-cover siya sa first law of motion. So, kung dili gali ni siya mabalance ang kaniyang iyahang mga forces, then it is not covered by the first law of motion. So, kanus araman siya na ma-cover siya sa first law of motion if the forces are balanced, just like this. Okay? So, it should be like that. Okay, so for here, unbalanced force. What about if your forces are unbalanced? Kanus sumambon siya nga na. So, ningon ta ganina na pag naay gravity, we have Fg. We have gravity that pulls downward. Let's say this is 5 newtons. Then, you also have your normal force, which is 5 newtons. Now, remember, kaning normal force is magdepende rin siya kung naa siya surface or wala. Kung wala siya surface, then wala yung normal force, ha? Kay, ang normal force, naran na siya kung naa surface, naa wall, kung naa surface. So, mo push back siya. Let's say, musumbag ka sa wall. Pag sunbag ni mo na kay normal force. Gihatagan ni mo siya force, ang wall pod, naghatag balik sa imo og force. And that is also a normal force. Okay? So, depende na siya kung naa kay surface or wala si normal force. Dili na siya present. Unlike gravity. Si gravity naman kita, as long as you have mass, you will have this weight or the force of gravity. Okay? So, si normal force is independent kung naa siya surface. So, here, ningon mo siya na naay table, so naay normal force. So, here, you got canceled out. Canceled ang imong normal force and imong force of gravity. Pero, napakaibilin nga force. And that is the friction between the table and book surfaces that exerts a leftward force upon the rightward moving book. Okay, so it means na siya bilin nga force. Okay, so here, that is what we call unbalanced. Kaya naa siya bilin nga force. That is unbalanced force. So pag unbalanced na gali ang force, dili na siya appeal sa first law of motion. Remember that. Okay, so for example here, Luke drops an approximately 5 kilogram box of shingles, or weight is 50 newtons, off the roof of his house into the swimming pool below. Upon encountering the pool, the box encounters a 50 Newton upward resistance force assumed to be constant. Which one of the velocity time graph best describes the motion of the box? Support your answer with sound reasoning. Okay. So, asa daw diri ang graph na maka-explain sa motion sa gidrop nga box ni Luke. Okay, so ninyo siya diri. The weight is 50 newtons. Okay. Padulong siya, pababa siya. So you expect that the graph is also going down. Yan naman, kaya naman siya force of gravity. So it should be going down. Okay? Now, pag encounter daw niya sa pool, the box also encounters a 50 Newton upward resistance force. So, if padulong siya pababa, then pag abot niya sa swimming pool, naka-encounter siya 50 newtons. Ang weight niya is also 50 newtons. So, it means, at that time na pag-encounter niya sa swimming pool, it will have a balance force. No? So, the only thing that is balanced around here is letter B. No? Paubos siya, that is katong pag-drop niya, gikan sa roof, so it is going down because of the gravity, no? Tapos, pag encounter niya sa pool, it will have a balance. So, mo straight line siya. So, the answer here is graph B. So, pag ubos niya, then, nag-balance na dayon sila, each other. Dili siya pwede si graph A, because si graph A, walay balance na nahitabo. So, though ni baba siya, pero ni taas na po siya, which is not. Okay, pareho good sila na 50. So, wala dapat unbalanced force na mabilin. Walay sobra. So, dapat straight ra na siya. Okay? Dili pud pwede si C, kay baliktad pod. No? Nagbalance sila una, then ni taas. So, this is not letter C. This is not letter A. So, the answer is letter B. Paubos siya, katong pag-drop niya, and then, nag-balance sila duha. So, it is letter B. Next is, which one of these dot diagrams best describe the motion na gihimo ni Luke sa ihang box? Okay, so, kaning arrow daw, kaning mga arrow is where is the point at which the box hits the swimming pool. Kani siya daw na mga line is katong na hit na daw sa box ang water. Okay? So, which of these following dot diagrams describes the motion of the falling box as they drop to the time that they hit the bottom of the pool? Okay? So, the answer here is letter A. Yan naman. It is because it is going down at a faster rate. Then, pag abot niya sa pool, is mura na siyang equal. Depicting na nag-equal tong 50 newtons na weight ni box o 50 newtons upward motion or upward force ni swimming pool. So, equal na dapat sila pag abot nila diri a. Dili man pwede sa letter C kay wala man kay nakita na equal dira a. Dili man siya equal. Dili apod, wala equal. Dili equal ang spaces sa mga dots, no? Kani siya noon sa letter B, kani unahan niya, nag-equal siya, equal. But that is mali pod ang timing. Okay. So, dili pwede si C, dili pwede si B, so that is letter A. From that, nahulog siya. Then, pag abot niya sa pool, nag-equal na dayon ang motion. So, that is letter A. Okay, so, several of Luke's friends were watching the motion of the falling box. Being physics types, they began discussing the motion and made the following comments. Indicate whether each of the comment is correct or incorrect. Then, support your answers. Letter A. Ang isa niya ka-friend ingon na once the box hits the water, the forces are balanced and the box will stop. Is it correct or incorrect? That is actually incorrect. That is false. Unsay naka-incorrect ani niya? Tama man na forces are balanced. Yes, pag hit niya sa waters, the forces will be balanced kay pareho sila nga 50 upward and downward from the gravity. Pero ang nakamali niya is ningon siya, the box will stop. No, the box will not stop. No, just because the forces are balanced doesn't mean that the box will stop. Since nag-move naman siya daan, and then ang forces niya is balanced, diba? The first law of motion states that if it is already in motion, it will remain in motion. So since the forces are balanced and the box is already moving, the box will not stop. Incorrect na siya. Mag-move gihapon siya in the same speed and same direction. Okay? So, it will not stop moving, pero mo stop ang iyang acceleration. Okay, mo stop ang iyang acceleration. Dili mo, the same ra gihapon ang iyang velocity, iyang speed. Okay? Pero ang acceleration niya, mo stop na kay the forces are balanced. Mao ba na siya ang di mailhan nga na kay first or na siya law of inertia if it is both the acceleration is 0. Okay. So letter B, upon hitting the water, the box will accelerate upwards because the water applies an upward force. That is also incorrect. Dili siya mo-accelerate upwards or mo-bounce back. No, it will not bounce back. That is because the forces are balanced. Okay? So, if the forces are balanced, dili siya mo-bounce. Dili siya mo-bounce. Okay? So, the box will continue in motion with constant speed. Downward gihapon siya. Okay? Letter C. Upon hitting the water, the box will bounce upwards due to the upward force. That is still incorrect. Incorrect gihapon. Okay? So, why? It is because wala may unbalanced force. So, the reason that there is this bouncing effect is if na ay unbalanced force. Pero since equal man sila, walay unbalance. So, there's no reason for the box to bounce. Okay? So, that is why that is incorrect. Also incorrect. Next, if the forces acting upon an object are balanced, then the object is... So actually, this is A or B. Okay, so it must not be moving or must be moving with a constant velocity. Pag forces are balanced. Okay, yan ang dili man pwede si letter C. That is the reason marag result na siya. Result sa letter A and sa B. Wala siya nag-accelerate. It is because it is not moving and it is moving with a constant velocity. No, so, duha man to kabuok ang pwede ma-result if the forces are balanced. It will be at rest and it will be moving at the same velocity and the same direction. So, pwede si A, pwede si B, but not C. Okay. So, that is for the part 1 of part 1 of the laws of inertia. So, dira sa na ko i-stop ang sa first law. Then next, we will proceed with the forces. What is force and unsay mga types of forces? Peace.